after studying, after doing the question of mean, median, and mode with in all the series, let's understand the difference between mean, median, and the mode. So, as all these three, mean, median, and mode, are the measure for calculating central tendency. These three are the part of central tendency. So let's understand the difference between these three. So when we calculate mean, so basically mean is an average that is taken for a set of number. Okay, when we take calculate average from a set of a series or from a given series from a given data set, then that is called mean. Okay, now median. So basically the middle value of a given data is known as the median. So we have given a data series. First of all, we have to arrange that series in ascending order and or in descending order. Then the middle value of that series will be the median. Okay, so now mode. So basically in mode, the number which occur most number of times or most frequently in a given list or in a given data series, then it will be called mode. Okay, so most frequently occurred number is basically mode in a given data series. So this is the basic meaning of mean, median, and mode. Now, how we will calculate mean, median, and mode in a given data series? So, in mean, what we have to do, we have to do the sum of all the number which are given in a series. Okay, we have to add all the numbers together in a given data series, and after that we will divide the sum of all the value by the total number of the values. Okay, suppose there are five values in a given data series, 1 2 3 4 5. So first of all we have to add all the five value, 1 plus 2 plus 3 plus 4 plus 5, and then we will divide it by the total number, which is 5. So that is how we can calculate the value of mean. Now, how we have to calculate the value of median? So, what we have to do first, we have to arrange the given data series. We have to first place all the numbers in a given data series either in ascending order, either in a descending order. In whatever way you arrange the series, the answer will be same. Okay, suppose you have first arranged the series in an ascending order, then the middle value of that series is the answer of median. Suppose there are five number 1 2 3 4 5, which we have arranged in ascending order, then the mid value is 3. So the 3 is the median for that particular data series. Okay, now mode. So mode show the frequency of occurrence basically. So the number which occur more frequently in a given data series, that particular number is mode. Okay, if there is a series of 10 number is given and a particular number 3 is occurring 3 times in a series, then the 3 will be the mode of a given series. Okay, so in mode there is chance that it can be 2. The value of mode can be 2, or the value of mode can be more than 2 also. If in any given series that two particular number are occurring equal times, then the value of mode can be 2 also. Okay. Next, so basically when we calculate mean, so the result of mean basically known as average score. Okay, when we calculate mean, the result we got from while calculating the mean by adding all the numbers and dividing it by the total number, that answer will also be known as the average score. Okay. So, and in median, the middle number or the middle value of a given series is known as the median. Okay. While doing the practical question, we denote it with M. So the formula of median number is denoted by the formula of median is denoted by the M, and the formula of mean is denoted by the X bar, as we have already done in numerical question. And while calculating mode, we can have more than one mode. We can get one mode, we can get more than two mode also, and there is also probability that there will be no mode. So the mode will be denoted with the symbol of Z when we do the calculation numerically. So the mode will be denoted by Z. Okay. So, as in mean and median, there will a single value which come while calculating the average of a series, or a median or mid value of a series. But while calculating mode, it can be chance that the value of mode can be 1, 2, 3, or it can be 0. Okay, or it can be, you can say not 0, but you can say that there will be no value of mode. Okay. Now, the data type required for all these three measures of central tendency is, when we calculate the mean of a given series, so it is preferred that the data should be normally distributed. Okay, when we calculate mean, then data set for, on which we are applying the mean formula, that data should be normally distributed. Okay. And for median, the median is the most accurate representative when the data distribution is skewed. So basically, skewed is that data which is created an uneven distribution on a graph. Okay, when there is an undistribution skew, undistribution in while preparing a graph, that data is basically known as skewed data. Okay. So now mode. So basically the mode is preferred where there is a nominal distribution of data. So this nominal distribution of data we have earlier also discussed. Nominal distribution of means when the data type represents basically category. When there are categories in data, then that is known as a nominal distributed data. Okay, categories like gender, male, female, color, red, blue, green. So this type of categories and label, when we give some values, so, some qualitative data, then that data will be nominal distribution of the data. Nominal distribution of data, the value of mean, median, and mode basically are equal. So this is the systematic plot, basically a systematic plot of data around the mean value. Okay, so when data is nominal distributed, then we can preferably apply mode on that data. So now, uh, next, what an arithmetic mean, or you can say mean, is known as. So basically, mean calculation of mean is a measure of central tendency, and mean can be calculated by three measures. We do the if we have to know the types of calculating mean, then there are three types: arithmetic mean, simple mean, and weighted average mean. Okay, so basically till now we have studied the calculation of arithmetic mean. So we oftenly use arithmetic mean while doing the calculation for a given series, and it is also known as a simple average mean and weighted average mean. Okay, now median. So when there are even number, so uh, this point we have already discussed while calculating the median. When in a given series the total number are even number in a series, then the median is very simple to calculate, or we can say the median is the simple average of the middle value. Okay, and if the total, or you can say the total number of series is an odd number, okay, so then answer will come in fictions, so it is much difficult to calculate the very slightly difficult to calculate the median value. Now as in mode, there is no mode if there is a single data set. Okay, let's see an example, as we have already discussed so many example in previous lecture. So let's once again see the example of all these three: mean, median, and mode. So when we calculate mean, so there is an example to find out the average of four number 2, 4, 6, and 8. So what we need to do first, we have to add all these four number: 2 plus 4 plus 6 and plus 8, and we have to divide it by total number, which is 4. Okay, so the while after adding all the four number, the answer is 20. We have to divide it by the total number in a given series, which is 4. So 20 divided by 4, the answer is 5. So average mean of this series 2, 4, 6, 8 is 5. Okay, so this is how we calculate average, or we calculate mean. Now median, as median is the mid value of a series. So there is a series given 4, 2, 8, 10, and 19. So the first step for calculating median is that first of all we have to arrange the data in ascending order. So let's arrange this data in ascending order is 2, 4, 8, 10, and 19. Okay. So after arranging the data in ascending order, we have to identify the mid value. So for this, the mid value, as there are five numbers, so the mid value is 8. Okay, so as in this given series there are total five numbers, so the middle value in this series is 8, which is also known as median. So median is equal to 8. Okay, after that, how to calculate mode. So example is there is a given series 3, 3, 5, 6, 7, 7, 8, 1, 1, 1, 4, 5, 6. So we have to find out the mode for this given series. So what we have to do is, we have for this also we have to arrange this series. So first arrange the series in ascending order, then see which now which particular value is occurring most frequently. Okay, so in in this given series, the number 2, number 3 is occurring two times. Okay, number 5 is also occurring for two times. Number 6 also occur two times, and 7 also two times. Uh, but 8 is occurring only one time. Okay, the frequency of 8 is 1, and the value 1, the frequency of occurring of value 1 is 3. Okay, and the value 4 is also again occur only one time. So in this given series, the number which with the highest frequency is basically known as mode. So the value which occur most frequently and have the highest frequency in this given series is 1. So here in this series, so value of mode is 1. So this is how we calculate mean, median, and mode. So this is the basic difference between mean, median, and mode. Now we will understand, we have discussed mean, median, and mode. Now let's discuss the geometric mean and the harmonic mean. So as till now, we are well aware with the finding with the square, cubes, and other power of the base. So also we know about the square root, cube root, and the nth root of a number. So, as we are aware about the reciprocal of a number and its importance also. So, what all are these in statistics? Basically, what is the use of these in statistics and how they are helpful in statistics when we calculate cubes, square root, nth number, cube roots? Then what is the use of these in statistics? How they are helpful in statistics? So basically the all these form are the basis of calculating geometric mean and harmonic mean. So they are very helpful in statistics, and they help basically in calculating geometric mean and harmonic mean in business statistics. So let's get start to learn more about the harmonic mean and the geometric mean. So as in our syllabus, we need not to go for the numerical part for geometric mean and harmonic mean. We will understand the base of calculating geometric mean and harmonic mean. Okay, we will discuss its meaning, their advantages, their disadvantages. Okay, so basically, we will discuss their objectives and their meaning in this lecture. So basically, geometric mean and harmonic mean form an important measure of central tendency. As we have already discussed three measures, arithmetic mean, median, and mode. These two also, geometric mean and harmonic mean, both these are also the form of calculating central tendency of a data. So basically, they tell us about the central value of the data. Basically, they tell us about they tell about which all the sets of value of a data set are lies. So suppose we have a huge data set and we want to know basically about the central tendency of the data. So in that case we use harmonic mean and geometric mean also. So we have so many ways so that we can calculate central tendency for a given data. uh, but what if the data set are fluctuating, or we need to add or we remove the some value of data? So when we have a large data set and the value of that particular data sets are fluctuating, and on time to time we need to add some value on that data, and we have to remove some value from that data. For that purpose we need to calculate the average value or the central value, which will be tiresome or troublesome the task. Okay, so we use geometric mean and the harmonic mean for this purpose. Okay, when data sets are fluctuating and we need to remove some data and some value in data, and we have to add some value in data, for basically that purpose we need to calculate, we should go for geometric mean method and harmonic mean method. Now first start with the geometric mean method. As geometric mean is a measure, basically geometric mean is a measure of central tendency that is particularly useful for the set of positive numbers. So while calculating geometric mean, it is basically calculate by multiplying all the numbers together and then take the nth root of the value. Okay, so in a geometric mean, or you can say average, in geometric average, which show the central tendency of a set of data or set of number by using the product of their value. For a set of n observation, a geometric mean is the nth of their product. Basically, the geometric mean is a type of average that indicates the central tendency of a set of number by using the product of their values. So as it is a part of calculating central tendency, it is specifically used for set of for positive numbers, and it is particularly effective in various fields. Fields like finance, economics, business statistics, education, policy making, etc. So the geometric mean is basically defined by this formula, or you can say it is mathematically expressed as by this formula, which is given on your series. So basically what we have to do, so first of all we have to multiply all the values together, the data set which is given to you. First of all you have to multiply all the values together, then you have to take the nth root of the product. Okay, where n is the number of value. Multiply all the values together, then take the nth root of the product where n is the number of value. Okay, number of value, n is number of value. This concept we are studying from the starting of central tendency. Okay, so this is how we calculate geometry mean, which is defined mathematically by this formula, which you can see on your screen also. Okay, so as we understood that the geometric mean is a type of average that indicates the central tendency of a set of number which you use, which is, or you can say that the number by using the product of their values. Okay, so it is especially useful for the set of positive numbers, that is particularly effective in finance, economics, business statistics, in mathematics, or etc. in various fields. So now let's understand the applications of geometric mean. What are the application of geometric mean in business statistics basically? So as geometric mean is helpful in calculating the growth rate. It helps in calculating index number. It helps in calculating investment return. So basically, geometric mean is used for large data set where values can fluctuate, when value can be added uh, very frequently, when values are subtracting very frequently from a data set. So how basically this geometric mean helpful in calculating growth rate? So basically the geometric mean is widely used for calculating average growth rate over multiple periods. Okay. So for example, it is used to determine basically the compound annual growth rate, which is CAGR. Compound annual growth rate is also known as CAGR, which is measure of the mean annual growth, which is the average of the mean annual growth rate of an investment over a specific period of a time, which is longer than 1 year. Okay, so basically it is used to measure the mean of annual growth rate of an investment which are done by a person over a specific period of time, and that time period will be for longer than 1 year. So this is how geometric mean helps in calculating growth rates. Now, how index number helps in calculating geometric mean? Sorry, how geometric means helps in calculating index number. So basically, geometric mean is very useful. Basically, geometric mean is very useful in constructing index numbers such as consumer price index or stock market index. Consumer price index is denoted by CPI. So, geometric mean is very useful in calculating index number like consumer price index or stock price index. So, these indicate indices. So basically, these indices often involve ratio and percentages which benefit from the properties of the geometric mean. So this is how it helps in index number. Now, how geometric mean is helpful in calculating investment return. So as geometric mean is also applicable on investment return. So basically in finance, the geometric mean is employed basically to calculate the average return on investment. So over multiple periods, when we calculate average investment return in finance, so basically it geometric mean basically helpful in calculating ROI over a multiple period. So basically this take into account the computing effect of investment return, which is provide a more accurate reflection of performance compared to the arithmetic mean. So basically, geometric mean helps in calculating investment return, which provide a more accurate reflection of performance as compared to the arithmetic mean. So now basically, apart from arithmetic mean, geometric mean is used for large data set in which fluctuation are very common and in which in which addition of value and subtraction of value are going on from time very frequently. So for that data set, geometric mean is very helpful for the calculation, as this geometric mean is applicable in business statistics in various way. It helps in basically it helps in calculating growth rate. It helps in finance for calculating average return on investment. It helps in calculating consumer price index and stock market index. So this is how it is helpful. Now let's discuss the advantages and disadvantages of geometric mean. So there are three advantages and disadvantages we are going to discuss for geometric mean. Advantages are compounding effect, reducing impact on outlier, proportional data, and disadvantages are complexity, interpretation, and limited to positive number. So let's first start with advantage. So first one is compounding effect. So as geometric mean is accurately reflecting the compounding impact of the growth rate or the investment return over a time, which make it appropriate for those contexts which are used for arithmetic mean, or you can say other than the arithmetic mean. Basically, as I have discussed in previous topic, that the calculation of geometric mean is applicable in various field of business statistics. So basically it calculate the effect of growth rate, or you can say index number and average return on investment, and which basically helps over a period of time and make it appropriate in every context. Okay, other than the arithmetic mean. So it is applicable in various fields of business statistics, and it is showing a good impact, or you can say a healthy effect of its calculation. Next is reducing impact of outliers. So basically, geometric mean reduces the impact of very large or very small value compared to the arithmetic mean. As arithmetic mean cannot unable to reduce the impact of large value and very small value in a data series, but geometric mean helps in reducing the impact of the outlier, or you can say the impact of large value or the small value. So, by focusing on the product of value rather than their sum, so the geometric mean basically reduce the influence of extreme large value and extreme small values, which provide more blended message. Okay, so this is how geometric mean work, and it reduce its impact from the outliers, means from the which the value which can influence the geometric mean values like extreme large values and extreme small values. Next is proportional data, as it is more appropriate than the arithmetic mean for the set of number that are meant to be multiplied or together, or are you can say they are multiplied together. So in this situation, for data that are multiplicable, or you can say exponential in nature, as it preserve the proportion relationship among the data. So it is more appropriate method than the arithmetic mean, where the data, when we have the large data set or the set of large number which can be multiplied together, or which can be exponential in nature. Also, geometric mean helps in growth rate, as it is useful in growth rate. Basically, the geometric mean is particularly useful in calculating the average growth rate, or such as it helps in compounding annual growth rate in finance. As we have already discussed in the application of geometric mean in statistics, it helps in calculating index number, it helps in finance for calculating investment rate, also it helps in calculating growth rate. Now let's come to the disadvantages of geometric mean. As first disadvantage is limited to positive number. So basically, the geometric mean can only be calculated for positive numbers. So when in geometric mean, you can say the value only be calculated for positive numbers. If there are negative or zero values in a data series, then the use of geometric mean is inappropriate, or you can say it is undefined. You cannot use a geometric mean for negative data set or the zero value data set. Okay, the value you require for calculating geometric mean, it should be positive numbers. The set you are taking for calculating geometric mean, it should be in positive numbers. It should not be zero, or it should not be negative value. Next is complexity. So basically, it is more complex to compute, to calculate as compared to the arithmetic mean. The calculation of geometric mean is more complex as compared to the arithmetic mean. It requires basically multiplication and extraction of the roots. which might be which might be more difficult than the calculating of arithmetic mean. So it is a complex method of calculating mean by with the method geometric mean as compared to the arithmetic mean. Next is interpretation. So, in the context of interpretation, the geometric mean may be less interpreted to those who are unfamiliar with its application. So, as geometric mean is very easy to understand and very easy to calculate, by seeing the data set. Okay, but in geometric mean you cannot easily interpret the application, or you cannot easily interpret the solution of geometric mean. It is difficult than the arithmetic mean to interpret the use of geometric mean or the calculation of geometric mean. So, on the basis of these above advantages and disadvantages of geometric mean and the application of geometric mean, we can say that the geometric mean is basically a powerful statistical tool in business statistics, especially for analyzing growth rate, for calculating investment return, for index number, for calculate and basically its ability to account for compounding effect and reduce the impact of outlier, basically make it a more valuable measure of central tendency in various applications as compared to arithmetic mean. So, however, its limitations such as restriction and positive value are the complexity of its calculation, and it should be considered that when we determine its appropriateness for giving data set, it is very important that geometric mean is very useful statistical tool for business statistics.